Alright, so for today we are going to be talking about exponential growth and decay application questions. How do we apply this knowledge that we have of exponential functions to a question? And so first off, there's a formula, and it is not all that different from what we've been working with, but it is a little bit different. So I wanted to kind of walk through this formula a little bit. It's still using an exponential function. We're just adding a few pieces in there to make it a little bit easier and a little bit more of a plug and go kind of formula. So here it is. It's going to be y is equal to a multiplied by 1 plus r raised to the power of t. So we're not using x, we're going to be using t this time. And we've also added in r and a. And this will just kind of help us walk through, answering these types of questions. So specific to these growth rate questions. So A represents our initial amount, R represents a growth rate, and T represents time. Okay, and so we're just going to take this basic information and kind of plug it in and work with what we've got here. So the original value of an investment is $1,400. So original value, that's going to be an initial amount. So I'm going to call A equal to $1,400. The value increases by, tells me that is a growth, and then 9% makes that a rate. We do have to convert that 9% into a decimal, so we're going to move the decimal 2 places to the left. So our rate is going to be 0.09. Okay, and it increases each year. That's going to be our timeline here. Now, we use an exponential growth function to find the value of the investment after 25 years. So we're looking for when t, time, is equal to 25. And notice that my units are the same, so I don't have to make any conversions here. Alright, so I'm going to plug this in. Y is equal to, A is 1,400 multiplied by 1 plus 0.09 raised to the power of 25. And so we're just going to plug this into our calculator. I'm going to do 1,400. I am going to go ahead and add my 1 and 0.09 together and then raise that to the power of 25. And so in my calculator, I'm going to plug this straight in. So 1,400 multiplied by 1.09 raised to the power of 25. And I'm going to press enter. And I find 12,072.31292. Okay, now this is an application question, so we do need to be thinking in terms of units. So we're looking for the amount of money after 25 years. So I do need to make sure that I write this in the terms of money. So I'm going to use a dollar sign, $12,072, and I'm going to round this to 2 decimal places, in this case 31 cents. Okay. Alright, let's look at one more example just to kind of get you going here. So number 5 is the population of a small town is 1,600, is increasing at a rate of 3% per year. And I use an exponential function to find the population of the town after 10 years. So again, we have a population of 1,600. That's an original amount. It's increasing at a rate, this is our growth rate, of 3%. And I am going to go ahead and change that to 0.03. And then finally, we're looking for what happens after 10 years. And it is increasing per year. Our years are matching, so our t is going to be 10. So I'm going to plug this in. Y is equal to 1,600 multiplied by 1 plus 0.3 raised to the power of 10. And I am going to go ahead and add these two together and get 1.03. And then I'm going to go straight to my calculator. So 1,600 is population multiplied by a growth rate of 1.03 raised to the power of 10. What's going to happen after 10 years? And we get this 2150.266207. Okay, and we're asked to find the population. Population is talking about people. So when we write this out, we're going to write it in terms of people. And so there are 2,150, and we're going to double check it doesn't round up or down. We're not going to have a 0.2 of a person. And since that doesn't round up, we're going to leave it as 2,150 people for our final answer. Okay, so that's kind of how the exponential growth works. Let's go ahead and talk through what exponential decay looks like in the next video.